Continuing the discussion on the heavier 14 group elements, compounds and the reactions, we continue with the silicon compounds. Then we come to the silicates. These silicates include many classes as well as the gemstone known as opal, which typically contains 10 to 15% water. In a large and important class of materials called aluminous silicates, some of the silicon atoms are replaced by aluminum atoms to give aluminosilicates such as zeolites, whose three-dimensional framework structures have large cavities which are connected by tunnels. Zeolites are aluminosilicates with large cavities connected by channels. So, because of the cations in zeolites, they are readily exchanged, and zeolites are used in laundry detergents as water softening agents because of their tunnel property. The more loosely bound sodium ions inside the zeolite cavities are displaced by the more highly charged Mg2 plus magnesium and calcium ions present in hard water, which bind more tightly. Zeolites are used also as the catalyst and for water purification. So we see how useful these silicates are become with the combination of aluminum atoms. Zeolites are aluminosilicates with large cavities connected by channels. The cavities normally contain hydrated cations that are loosely bound to the oxygen atoms of the negatively charged framework by electrostatic interactions. The sizes and arrangements of the channels and cavities differ in different types of zeolites. For example, in zeolite A, the aluminosilicate cages are arranged in a cubic fashion, and the channels connecting the cavities interact at the right angles. In contrast, the cavities in fungicide are much larger, and the channels intersect at 120-degree angles. In these idealized models, both, that is fungicide and the zeolite, the oxygen atoms that connect each pair of silicon atoms have been omitted. This we can see how the difference due to the channels take place in zeolite and fungicide and how their properties differ from each other. Silicon and germanium react with nitrogen at high temperature to form nitrides N3 and 4. And similarly, silicon nitride Si3N4 is formed. It has the properties that make it suitable for high temperature engineering applications. It is also strong, very hard, and chemically inert, and it retains these properties to temperature of about 1000 degrees centigrade. So again, silicon nitride is also very useful in engineering applications due to its resistant to high temperature property because of the diagonal relationship between boron and silicon, metal silicides and metal borides. Although metal silicides have structures that are complex as those of the metal borides and carbides, few silicides are structurally similar to the corresponding borides. Due to the significantly larger size of silicon, atomic radii is 111 pm, versus 87 ppm for boron. Silicides of active metals such as Mg2Si are ionic compounds that contain the Si4- ion. They react with aqueous acid to form silicon hydrides such as SiH4. Here we see this formation of silicon hydride from the Mg2Si reacting with the aqueous solution of hydrogen ion to give magnesium ion and gaseous SiH4 silicon hydride. Unlike carbon, catenated silicon hydrides become thermodynamically less stable as the chain lengthens. Thus, straight chain and branched silanes analogues to alkanes are known up to only n is equal to 10, that is 10 number of silane molecules are bonded with the chain. The germanium analogues germanes are known up to n is equal to 9, likewise as that of the silanes. In contrast, the only known hydride of the tin is SnH4 and it slowly decomposes to elemental SN, tin and hydrogen at room temperature. In case of hydrides formed with lead or PbH4 lead hydride that is so unstable that not even certain that it exists or not, because E double bond E or E triple bond E bonds, here E is any group 14 element, become weaker with increasing atomic number. Simple silicon, germanium and tin analogues of alkenes, alkynes and aromatic hydrocarbons are either unstable like Si double bond Si and Ge double bond Ge, or either they are unknown. Silicon based life forms are therefore likely to be found only in the science fiction. The stability of group 14 hydrides decreases down the group, and similarly E double bond E and E triple bond E bonds become weaker. That is, again here E represents the any element of group 14. The only important organic derivative of lead are compounds such as tetraethyl lead. Because the lead and carbon bond is very weak and these compounds decompose at relatively low temperature to produce alkyl radicals, which can be used to control the rate of combustion reactions. For 60 years, hundreds of thousands of tons of lead were burned annually in automobile engines, producing a mist of lead oxide particles along the highways that constituted a potentially serious public health problem. We all have heard how much pollution this lead causes as it is present in the automobiles. The use of catalytic converters reduced the amount of carbon monoxide, nitrogen oxides, and hydrocarbons released into the atmosphere through automobile exhaust, but it did nothing to decrease lead emissions. Because lead poison catalytic converters, however, its use as a gasoline additive has been banned in the most of the world.